When calculating numbers to get you a result, so we have some numbers multiplying numbers to get you some result, this result must have the least number of significant figures, sig figs, of the number you multiplied by. So if we have a number with 3 significant figures multiplied by a number that has 2 significant figures, your result must have 2 significant figures. It must have the least number of significant figures. If I multiply a number with 7 sig figs and another number with, that has 8 sig figs and another number that has 9 sig figs, then the least number of sig figs for the result is 7 sig figs. Okay, so now let's do a practice problem. Let's say we have 9.69834 multiplied by 0.003. Now this number has 1, 2, 3, 4, 5, 6 sig figs. And this number has, well, this is not a sig fig because it's a leading zero. This is not leading zero, leading zero. This one has 1 significant figure, 1 sig fig. So if we do 6 sig figs times 1 sig figs, well, we know our result must only have 1 sig fig. Okay. So let me just clear all this red up. Okay. So I did the calculation and it's equal to 0.0029. Okay, so this is the rounding digit. This is the adjacent digit. Adjacent. This is the rounding. So we want 1 sig fig, recall. We just want 1 sig fig. So 0.002. Adjacent is greater than 5. So we round up r plus 1, right? So we're left with 0.003, 0.003. This 2 becomes a 3. And you can see there's only 1 sig fig, right? So this is the answer for this multiplication problem. Okay, let's do another one. So the same idea is applied for dividing, right? We take the result must have the least number of sig figs with the numbers you're dividing by. So if we have like 58.040 divided by 16, well, this top number has 1, 2, 3, 4, 5 sig figs. This bottom number has 2 sig figs. So 5 SF divided by 2SF equals 2SF. We must have the least number of sig figs for dividing numbers. Okay, so we know our result must only have 2 significant figures. Okay, so this calculates to be 3.6275. We want 2 sig figs. So 1, 2. This is the rounding number. This is the adjacent number, which in the previous video I denoted as n. But I like a better, just for adjacent. Okay, so now let's rewrite this down here. 3.62. The adjacent number is less than 5, right? So we keep this the same. Keep it. So 2 sig figs, this becomes 3.6, right? That's the answer for this division problem. All right, let's do 14 times 10.1. Okay, let's count the number of sig figs. 1, 2, 1, 2, 3. This is an embedded zero. Embedded zeros are significant. So 2SF times 3SF will get you a result with 2SF because we want the least number of sig figs. Okay, so if we multiply this out, what we get as the result, put that one there, we get this equals to 141.4. And we want 2 sig figs, right? But we have 1, 2, 3, 4, right? So we go 1, 2. This is the rounding number. This 1 becomes the adjacent number. So let's just keep that in mind. 1 looks like an L. 1, 4, 1. The adjacent number is less than 5, so we keep this 4 as a 4. So this just becomes 140. Okay, and you notice we only have 2 significant figures. There is no decimal here, and therefore this trailing 0 is not significant. If this was that, if we had 140 decimal, right, then this would have 3 sig figs. But since there is no decimal here, then we only have these 2 sig figs. So 140 is the answer for this multiplication problem.